Okay, this is CodeForces problem B from contest 1108. This problem says we get a single integer, and then we have to find n positive integers such that if you add all of those integers up, each of those integers can individually divide that sum. Okay, so I'll give an example. If they give us the number 3, we need to come up with three numbers, call them A1, A2, A3, that the sum of them um, go to, like, let's call the sum A1 plus A2 plus A3 equals sum. And we need each A1 to divide S, A2 to divide S, and A3 to divide S. Three possible numbers for this. A1 could be 1. Um, this is one example. A1 could be equal to 1, A2 is equal to 2, and A3 equals to 3. Because in this case, you get 1 plus 2 plus 3 equals 6, and 1 divides 6, 2 divides 6, and 3 divides 6. So that's one scenario. The approach for this is now what do you do when you get a number 4? Okay, so 4, you need a bigger number now. So for when you get n equals 4, one interesting way you could do this is you could just why don't we keep our old sequence? We'll do 1, 2, 3, and add on a 6 because we're increasing the sum to 2s. Now our total sum is equal to 2s because a1, a2, a3 all divide s. We know they must all divide 2s. This is because of the divisibility of integer combinations. And then once we know this, um, we can just keep adding the sum as we keep appending the total to the end of our array. So for n equals 5 now, we would do 1, 2, 3, 6, and then the sum of this is 12 because now the total sum is 24. The total sum equals 24. And we know because everything, all of these numbers, 1, 2, 3 is 6, divided 12 before, and 24 is just 2 times 12, they will all divide 24 as well. And we know 12 divides 24 because we're just doubling the sum we had before. So this is a strategy in the general case. We still have to consider n equals 1 and n equals 2. So n equals 1 is easy because this is just one number. We can take 1 because 1 divides 1. But then 2 is a little bit different. This actually will return -1 because it isn't possible. It isn't possible. There are no numbers that multiply, and I'll give a proof of why this is the case. Okay, so okay, assume there is an A1 plus A2 uh, equals some sum. Then we have A1 divides sum, and then A2 divides sum. So A1 must divide A1 plus A2. And because A1 divides A1, thus A1 divides A2. This is because this is I think what this theorem is called is the divisibility uh, of integer combinations. Divisibility of integer combinations. I'll just do a quick proof of that. Integer combinations. Uh, so this proof is, let's say A divides B, and A divides C. And the claim is A thus divides bx plus cy, where x, y is in the set of integers. Okay, because we know A divides B, thus B equals k times A, and C equals j times A for some k, j in the set of integers. This is by the definition of divisibility. And now bx plus cy thus is equal to ka by substitution times x plus ja y. Okay, now we can factor out an a. This is equal to a times kx plus jy. Thus, by the definition of divisibility, we get a divides bx plus cy. So that's the proof for this. In our case, where we have a1 divides a1 plus a2, we're basic and a1 divides a1. We're basically just using this property because we're saying our b in this case would be a1 plus a2. So we're doing a1 divides a1 plus a2 minus a1. So in our case, uh, this would be y would be -1, I think. Yeah, y would be -1, and c would just be a1 in that case. And so yes, so basically from this we know a1 divides a2. What does this mean? This means a2 is equal to a1 times, I'll just call it k, or maybe I'll just use L. I think I've already used k somewhere. A1 uh, a1 times L for some L in the set of integers. Okay, so what does this mean? One, because in the problem it said all of these are uh, positive. I'm pretty sure it said this somewhere. Given a single integer n, positive integers. So these have to be positive. And because they're positive, um, L, A2 and A1 are both greater than 0. Uh, and then So A2 must be greater or it's equal to A1, but we cannot have that because they are also distinct. That is one thing the problem said. So thus A2 is greater than A1. Okay, A2 is greater than A1. And then now we can also say because A2 also divides A1 plus A2, A2 also divides A1 plus A2 from a similar property. We also get since A2 divides A2, um, thus A2 divides A1, and then we also get A2 is less than A1. These are contradictory, so this is uh, therefore we have a contradiction, um, and thus n equals 2 can't have anything. Okay, so that's a proof for n equals 2. I'll show the code. Okay, so basically what we're going to be doing, we're going to be taking in some test case t, and then we're going to be taking in an integer. And so I'll take in this integer in the case that we have three different cases. If nums equals 1, we'll return 1. Um, I'll just return, I'll return this as a number, I think. If nums equals 2, then we will return -1. Then the other case, if nums equals 3, this is like our base case, which we won't write. We're going to be appending to this. So basically we'll just have a vector. We should probably do this as a long for now. I'm not sure how big the numbers are going to get. Our vector is a long, and we're going to have our array be equal to 1, 2, 3, because this is in the case of 3. And then our int sum is going to be equal to our int sum. We'll do a long sum again. Long sum is equal to 6 right now. So then we're going to do for int I equals 0, I less than n minus 3, because if you consider the case where n is equal to 3, you wouldn't want this to run at all because you just want to return 1, 2, 3. So we'll do plus I, and then we'll keep pushing onto this array. So array dot push back, the sum, and then we'll multiply the sum by 2. Sum times equals 2, because we're creating room. Since that now the next one is also going to be dividing the whole, because it'll be 2 times. It'll be the whole divided by 2, basically. Okay, so now we have our array. That looks good. Now we just have to print this out. I guess we're kind of returning an array then. It would be better than if we actually, instead of return 1, we print this. So I'll just do this as a void function. Okay. So I'll do C out -1. Um, I'll do C out 1, um, new line. And then if in the return -1 case, we should do C out -1. Okay, we actually don't need this array uh, because we can just do it on the fly. We'll be printing it as we go. So I'll just delete this. We'll print out the 1, 2, 3 sequence beforehand. So we'll do um, C out 1, 2, 3. We won't do a new line yet. The new line will go after. C out. Okay. C out 1, 2, 3. And then we're going to need to add a space in. So for all the numbers that we are going through, uh, this should be none. Okay. For all the numbers that we are going through, we're just going to be also throwing them out to the standard output as well. I guess C out. So we'll do C out sum. We'll do a space first. Sum. Okay. And then sum times equals 2. Okay. This should work, I think. Let's try their test cases. So I'll just compile this. B, we'll do input. We'll put in input.txt. Okay, we get 1, 1, 2, 3, 1, 2, 3, 6. Is that what we expected? What was our input? There's 3 test cases. 1, we should be getting 1. I don't think this is what it should be. Let me just check if there's something. -1, 1. Oh, these should be returning after. We don't want them to keep going through. Okay. 1, 1, 2, 3, 6, 1, 2, 3, 6, 12. Okay, this should be the answer then. Okay, that is the correct solution. Okay, great.